Hello, everyone. Welcome to the TDWI webinar program. Thanks for joining us today. I'm Diane Schaffhauser. I'm a contributing writer for TDWI, and I'll be your moderator. Our program today is the Next Generation Data Integration Hub, a business-friendly publish and subscribe paradigm for enterprise data. Our sponsor is Informatica. And our first speaker today will be Philip Russum, TDWI's Research Director for Data Management. After Philip's presentation, we'll hear from Ronan Schwartz, VP and General Manager of Emerging Technology at Informatica. Okay, a couple of baseline items very quickly before I turn over the time to our speakers. Today's webinar will be about an hour long. At the end of their formal presentations, the speakers will host a question and answer period. If at any time during the hour you'd like to submit a question, just use the Ask a Question area on your screen to type in your question and send it over. We encourage you to ask as many questions as you like. If we don't have time to answer the questions during this hour, our sponsor will respond via email to unanswered questions. If you have any technical difficulties during the webinar, click on the Help area located below the slide window and you'll receive technical assistance. And if you'd like to discuss this webinar on Twitter with some of the hundreds of others joining you here today, just include the hashtag TDWI in your tweets. Finally, if you'd like a copy of today's presentation, use the Click Here for a PDF line there on the left middle of your console. In addition, we'll be emailing you a link to the archived version of today's webinar so you can view the presentation again later if you choose or share it with a colleague. Okay, again, our program today is entitled The Next Generation Data Integration Hub. Our first speaker is Philip Russum. Philip is a well-known figure in data warehousing and business intelligence. He's published more than 500 research reports, magazine articles, opinion columns, speeches, webinars, and more. As Research Director for Data Management here at the Data Warehousing Institute, he oversees many of TDWI's research-oriented publications, services, and events. Before joining TDWI in 2005, Philip was an industry analyst covering BI at Forrester Research, Giga Information Group, and the Hurwitz Group. He also ran his own business as an independent industry analyst and BI consultant and was a contributing editor with leading IT magazines. Philip, I'll turn things over to you here.
Well, thank you, Di, for that introduction, and also I want to express my special thanks to everybody attending today. I know everybody's busy, and I really appreciate that you could find time to join us today while we're here to talk about the next generation of data integration hubs. Now, to do this, I'm going to talk about hub and spoke architecture, and I know many of you are familiar with that, but stay tuned. I have a lot more to add that you probably haven't thought about too much. You know, hub and spoke architectures can be very simple, you know, with a handful of functionality on the hub and a few spokes for inbound and outbound data, or it can scale up to lots of functionality on the hub with hundreds and sometimes thousands of spokes and that sort of thing. So we also think of hubs as being something that you would see in deployment, but today I'm going to talk about that's true, but also the hub should support a lot of development activities and also collaboration between the technical people and business people. So if you think you know a lot about hub and spoke architecture, stay tuned, because the hubs we're going to talk about today are really a much more advanced form than most of us are familiar with, and in fact we're talking about the new generation that is upon us. And to describe this new generation, I'm going to talk about desirable characteristics of hubs, but I'll also hit a couple of undesirable characteristics just so you know what to avoid. I'll summarize at the end by tallying a list of 8 traits of the next generation data integration hub, and as always I'll end with some actionable recommendations. Now if you tweet on Twitter, please take note of some of the hashtags on the screen there and tweet a few of your thoughts about our webinar today while it's happening if you can, or maybe later. Okay, let's just take a quick look at hub and spoke architecture, get us all on the same page. And you know, this architecture really has become the preferred architecture for data integration. I would also say for application integration. A wide variety of tool types and vendor platforms do have this kind of architecture in mind. Although if you're prone to hand coding, you can also create your own hub and spoke architecture that way. And there are reasons why this is a preferred architecture in both data and application integration. It tends to reduce the number and complexity of interfaces. It's so that I'll talk a lot about generalizing interfaces and other development artifacts so that they can be reused across a wide variety of solutions. And that reuse actually reduces the number of spokes that have to be developed for the purpose of interfaces. And also the hub and spoke architecture, it's really easy to grasp. I mean, it's a simple concept. It's easy to visualize. On my slide, I have a ship's wheel, you know, the thing that you would steer a ship with or a yacht. And, you know, we think of that, or maybe a wagon wheel. It's really easy for people to just get the concept. And because of that, if you're the man or woman who inherits somebody else's work, since it's a pretty easy to understand architecture with recurring predictable patterns, you know, just the hub and its spokes, then you can figure out what other people have developed. You can get your head wrapped around it. You can debug their work. You can then add value to it more easily than you can if with other architectures, or too often the case when there's no architecture. We'll also see that it fosters reuse, standards, virtualization. Most hubs scale and performs if they meet a few requirements that I'll list later. So all the above can go through a myriad set of variations. So hubs, you know, they're often drawn conceptually as symmetrical with this perfect circle, but they can be asymmetrical. They can be have a lot more outbound spokes than inbound, and sometimes you actually have multiple hubs, and the hubs integrate together into an architecture. And you know, the real alternative that I see among user solutions is what's often called point-to-point interfaces or point-to-point architectures. I like to just call it the hairball, and I didn't make up that term. A lot of people just you know, look at the kind of mess you end up with, a lot of uncontrolled point-to-point interfaces, and it is a kind of hairball that's difficult to tease out. And this results when there's not really an architecture. Sometimes people say point-to-point architecture. I think it's really the lack of architecture. So you have an uncontrolled number of interfaces. These are impossible to decipher, maintain, figure out the dependencies, figure out what kind of flows will actually call multiple interfaces in the collection. How do you even see that without a hub and spoke? And then also, quite often, there's no attempt at reuse and standards. And interfaces in a point-to-point context can perform pretty well, I think, but there's no real overall optimization. And quite often these are coded as one interface at a time, and you can't even see how they might be called in sequence. And if you think about your average data flow, almost all of them will call a variety of interfaces and other spokes, as well as other components for both data integration and other things that are related, like data quality, master data management, sometimes event processing, and so forth. So you just can't, in this environment, you just can't really see how things go together into a workflow or data flow. And especially when this is hand-coded, the costs go up because the kind of people who can hand-code these kind of solutions tend to be kind of pricey from a payroll standpoint. So you put it all together, and the point-to-point hairball is quite a nightmare to deal with. So by comparison, let's define data integration architecture. Actually, I just want to take a step backwards here. I wanted to give you some examples before I started to define this. And I think a real simple base definition is that data integration architecture is simply the pattern made when servers relate through interfaces. This fits pretty well to data integration, as well as a lot of application integration architectures that may be based on technologies like message brokers, message queues, services, etc. But to add more detail, we can extend the definition and say that a good architecture typically has some predictable patterns, and the patterns, they're not there just to be predictable, they're also standards. So you would want to have standards with the way the interfaces are designed, but also a lot of standards for how transformational logic, how joins are to be done. You want standards for any kind of hand coding that's involved there. So you can see the hub, it's not just an architecture to get data flows organized. It's also an architecture to get developers and their standards organized. Likewise, the hub helps to foster collaboration. You know, more and more today, we see 6 to 10 data integration specialists on teams, and larger companies, we'll see 20 to 30. So my point is, you know, the old days when there was 1 or 2 guys in the company doing it are gone, and when you have a large number of data integration specialists, you need a development environment, which itself becomes kind of a hub for the developers to come together, to share work, to share their reusable components among each other so that the standards are known and shared across them, that kind of thing. And that gives you a lot of control, doesn't it? So a lot of control in the development environment for standards, also things like data governance and data stewardship, but even control in deployment, control of the performance, you note the failure and restart as you would through a tool, but in the hub, more people have visibility into that. So this is a lot that can be enabled into a hub, and I'm going to dive into the details here in a moment, but I really want to pause and just kind of differentiate between hubs and spokes. And in my opinion, the real secret sauce in this kind of architecture is the hub. Most of the feature set you'd be interested in is enabled by the hub, and kind of the spokes are development pieces that you create yourself to build out the architecture. And not all hubs are created equal. Feature sets do vary a lot when we look at various vendor brands for data integration hubs. But really, I want to contrast sort of the vendor world to the homegrown world, and I do see I still see a fair amount of hand coding, and then also just sort of mostly manual processes where people are, they get kind of a spare database management system instance, and they model some operational data stores and things like that that can contribute to integration, but are kind of a homegrown approach to it. And so I find homegrown solutions like that are typically feature poor. So for maximal features, and today I'm going to talk about a lot of features, you really should be looking at a vendor product to enable this kind of hub for you. So with that kind of background, let me start drilling into what's desirable. But first, I want to touch on an undesirable trait of some hubs. This is a joke on my part here, so I hope you chuckle a little bit. Are you familiar with an old product called the Roach Motel? It's basically a box for catching insects. So you pop some door opens on this box, you put it on a floor somewhere, and ants, roaches, other insects walk in. They get stuck on fly paper or something like that. I'm not really sure what's in there. And so the insects go in, but they don't come out. And a lot of data management and a lot of databases are like this, right? The data goes in, but relatively little of it comes back out. And so I regularly see, especially homegrown hubs, where there's a heck of a lot of data going in, but very little coming out. And I think, oddly enough, that can be useful. For example, a lot of times when people are getting started with a customer data integration type of project, you want to collect a lot of customer data and study it. I'm a huge proponent of data profiling. So if you want to collect data to study and profile it as a prelude to the major project, then that's fine. But a lot of times people just never get past collecting the data, never actually get to the solution. They spend so much time profiling it. So sometimes a Roach Motel or a Roach kind of hub will result from that. So that brings me to one of the more desirable aspects, which is that data can't be one way in like the Roach Motel. Data needs to go in and come out of the hub as well. And here I'm really thinking about deployment, but obviously this will affect the way you design things in development. And so think about the hub as being about multi-directional data flows. And, or you may want to think about it as a closed loop, like you see in a lot of data quality functions. They'll take data out of one database, add value to it, and then put it back in the same database. So think about multiple sources and targets. So it's not just a one-to-one mapping like with the Roach Motel from source into the Roach target. It's quite often one-to-many, as with customer data synchronization. A lot of times for a certain attribute of customer, you will have selected a system as your system of record for that customer attribute, and you want to extract that attribute of customer data from that source system, but then publish it outward to many different systems, and that's what synchronization is about. So we have this one-to-many, but you also have many one-to-one, as in data warehousing, right? Typically, you'll extract data from multiple sources. You'll do your joins, aggregations, as well as transformational processing, et cetera, at the hub, and then you typically push it to one target, like the warehouse. And so that's the main thing here. The Roach Motel is typically one way, just too simple. Really, the hub's going to support multi-directional data flows, some of them closed loops, one-to-many, many-to-one, et cetera. Now, another desirable attribute of the hub is that it provides control. And control can mean a variety of stuff. So the hub itself can control data access and movement. Data access in the sense of compliance. You want to be sure that you have security, data privacy rules are respected by data integration. You have various definitions of data governance there as well. Also, the hub controls data integration operation. One of the great things about data integration tools is the powerful scheduler. We sometimes forget that, right? And homegrown solutions don't even have that, do you? So for homegrown solutions, a lot of times you have to get a third-party scheduler or something like that. So the hub provides stuff we would expect from data integration, like scheduler and all the restart. But it also has functions there for quality assurance and other collaborative operations. The hub controls design and development. It can help, since you have so many people with a central point, namely the hub, where they can collaborate as developers, then there's just a greater hope of them developing standards and sticking to them. And then also, you have architecture. My talk today, I assume architecture is a good thing, and I still occasionally find people who say, no, I don't really think data integration needs an architecture, does it? Well, yeah, absolutely it does, to get it organized and to have some of the advanced features that a hub can provide, like I'm talking about today. A next-generation data integration hub is fairly unique in that it supports publish and subscribe methods. I say unique certainly compared to homegrown solutions, but there's still a number of data integration tools and similar stuff like data quality, master data management tools that still don't support publish and subscribe. Let me tell you how it works, and then I'll tell you what the benefits are. The way PubSub, as it's sometimes called, works is it gives you a mechanism to certify and virtualize data as it's published into the DI hub. And you could certify other things as well, like development artifacts, interfaces, transformational logic, and that could be part of the reuse thing. But the certification here helps to identify data that is subscribable by a wide range of users, and it also helps you to get data into a canonical form, so it's trusted, it's ready for reuse by a variety of data subscribers. And the benefit of that is that, for one thing, users who need it have a business-friendly view of source data. They're not really looking directly at the source data. They're looking at some friendly view of it that was created for a publish and subscribe method. And therefore, different users, even business and non-technical users, can subscribe to that data on the hub. And when new data comes in, when the data is refreshed, then they're notified. That could even be pushed to them. This helps to enable some other desirable features like self-service for a very wide range of people. We often think self-service is for the non-technical people, but believe it or not, it's also to advantage to the technical folks. Data stewardship, where you need data folks with a view of the data so they can be true stewards. They can say, okay, I see the data, I can study it. Look, here's the data I think needs attention. From a data quality viewpoint, you fix this, you fix a lot of business processes. From a data integration viewpoint, this data I think is the trusted source for the new subject area in the warehouse or something like this that we're building. Data exploration is more important than ever, and this gets enabled more by publish and subscribe. Instead of actively going and hunting for data, a lot of people can discover data when it's pushed to them through some sort of subscribe methodology. And through all that, you can see that you're involving more business users in data integration, and in some organizations, that's really important. Well, let's move on. As I mentioned before, data integration hubs, not just for deployment, it's development too. So this is typically an area where you would develop artifacts and manage them centrally so that everyone can get to them, have some look at them. Technical developers have a better chance of establishing and keeping standards, of achieving reuse because they're able to see work created by other developers. But in some cases, again, not for everybody, but in some cases you do have non-technical or business people, especially those that serve as stewards, who want to have some look into the hub as well. So if development artifacts are managed in one place, Some business users actually want to see that to be sure that the sources they think are appropriate were selected, or the type of data quality functions they were hoping for get applied. And this helps users to develop generalized components for reuse. So think about reusable spokes, which are typically interfaces. Think about reusable development artifacts, many of them the logic for data transforms. And then also, one of the things we all need to be thinking about in terms of development methodology for data integration, whenever possible, you want to develop once, create an object that can then be deployed in a diverse variety of ways. And this is especially true for, say, write-time situations. Sometimes, the same interface, the same data transformation could apply for collecting data in a high latency batch orientation, but also in different situations the same stuff applies to more real-time or near-time fetch of the information. So that's just one example of how you would develop something once, but deploy it a wide variety of ways. This speeds up productivity for the developer, and since you're creating fewer objects, you actually get better compliance with your standards. All right, moving on, let's talk about write time. The term write time is really about speed or frequency of how data is fetched and delivered. We sometimes say it's about speed, and data has to go fast from, say, an ERP system through data integration through a warehouse environment so that a manager can refresh his or her management dashboard. So in a way, I guess that is speed, but there are also situations where frequency is more the issue. For instance, a lot of data is still collected, refreshed for a warehouse and similar environments on a 24-hour cycle, and yet more time-sensitive data, and you notice I didn't say all data, it's never all data, but for certain subsets of time-sensitive data, you want to also refresh that, 3 times during the business day, quite often, again, for managers who are trying to make tactical or operational decisions. And so the hub really needs to support what you need for this wide range of write time speeds and frequencies. And so you need really a broad range of interfaces to systems, and you pick the one that has the speed but also other characteristics you need. You would also look for certain technologies that enable real-time, things like service orientation, data federation, change data capture, in-memory processing is a real gainer. I see more and more of that all the time. And if you really want to go to the extremes, if you want true real-time in milliseconds, you may need some sort of event processing or even its advanced form, complex event processing. And I do see that in a few, not all, but in a few data integration tool suites and hubs, you will find that. So for the extremes of real-time, that is there in some hubs. Well, here we are in the age of big data, and there are different ways to define big data, but the primary one from which it got its name is massive data volumes. And so that is a scalability issue, isn't it? So you want to be sure that any data integration hub that you want to make an investment in and a commitment over time is going to be able to scale as big data gets bigger. And, that's easier said than done, isn't it? So what do you look for? What do you want to look for that's going to scale to big data? The really scalable data integration tools and hubs to go with them that I find out there typically have some sort of multi-server environment. It could be in the form of grid computing. It could be clusters. The leading data integration tools are available on clouds, and that takes care of the multi-server environment and assures scalability for you. I think data integration vendors have been very diligent because, their tools internally are lots of different components for integration stuff, transformations, but also a whole other body for data quality, et cetera. I think they've done a good job of going through all of that and making sure that all the components they provide work in parallel processing for the greatest speed. And, speed and scalability are related, aren't they? The faster you can complete a atom of or unit of work, then the greater the overall scalability of the aggregate system will be. And I think that's one reason why in-memory data integration has been growing in popularity. We've had data integration pipelines for many years, but I'm seeing higher adoption among users recently. But also, thanks to the shift a few years ago to 64-bit computing, the fact that the price of server memory has come down some, I don't want to overstate that, makes it more credible for putting more memory in your servers. Sometimes I regularly see some up to ½ terabyte, and I know a few for a terabyte. So that's kind of extreme for many of you, but you're thinking tens of gigabytes at least. This enables really a pipeline with large data volumes and with less input-output. You have greater speed and hence greater scalability. Well, as I drive towards the ending here, let me just kind of summarize some of the stuff I've hit on here today in a list of 8 traits for the next generation data integration hub. First of all, by nature, the hub should apply multiple data management functions in one development and deployment environment. And folks, that's not just data integration, which itself is a lot of stuff, from ETL to federation to replication, synchronization, event processing. Data integration itself is actually many disciplines and functionalities, but there's a wide variety of other stuff you should expect there. Data quality, which again is many functions. Standardization is really quite different from data append, which is different from match and merge, which has its related things like householding, etc. It's a lot of different functions you should expect in the hub, but also expect to development data flows that can call all of that. I mean, that's really where the user design of data integration solutions is going. One data flow that does a heck of a lot of stuff. And if you have a hub product that has all that functionality you want, it greatly simplifies design and development as well as controlling it in deployment. Number 2, look for hubs that support multi-directional data flows. Don't do the Roach Motel thing, which is one way and too simple. It's just 2 endpoints. Oh, no, you should expect the exact opposite of that. So expect a 2-way data flow into the hub and out of the hub. One thing I didn't mention earlier, typically when data comes into the hub before it goes out, we expect that it will be improved, right? So don't forget, and think about that in your designs. Vendor products have everything you need there to improve it. It's just, you should always be looking for ways to improve the data as it comes into the hub so that any systems and business users downstream have much better data along the way. Data quality is obvious, but also data aggregation is value-adding as well, especially with things like customer views. The hub controls data access and movement, and that ranges from data standards and development through governance and things like security. Publish and subscribe method, this is a fairly advanced feature. I still don't see it in many hubs, but this is really a really great thing because it's instead of you being proactive and having to find this stuff, quite often it'll find you through publish and subscribe. Number 5, the hub is for development. It's not just for deployment. I would also say it's for collaboration. It's not just a hub for data that brings data together. It's not just a hub that brings data integration functionality together. It's also a hub that brings a wide variety of people together so that the many data integration specialists I mentioned come together, but also they can collaborate with people there as well. The hub helps you to develop generalized components for reuse, supports a variety of write-time operations, and can scale to large data volumes. You're wondering, why now? What's the big deal? Well, I think many of you are trying to do some of the stuff the hub enables. Obviously, you're trying to deal with big data, and the hubs have proved their scalability. Many of you are trying to get more agile in development and the kind of collaborative environment that's not just collaboration with technical, but also with business, is fully aligned with the way Agile BI methods work. You have continuing cost concerns. By centralizing things, you can reduce some of the redundancies. Many of you are in the thick of compliance, other forms of governance, and by having a central place, again, you have a way to govern data, but also provide stewardship functions. Collaboration, I see users doing more and more of that in many different definitions, and the hub helps you do that, but the hub's also, through that collaboration, you can also get greater business alignment so that data integration work gives as much bang for the business as possible. So if you're thinking about getting started, you probably don't want to rip out your existing data integration solutions. You might instead look for something like a new project that needs data integration, like a new body of reports or dashboards. And then, acquire a data hub product if you don't already have one. You may need training as well. And then focus on the new development methods that I talked here, especially design data flows out of multiple reusable components and the flows that tap into multiple data integration functionalities. And this helps you decouple sources from targets, which is a whole new way of thinking that a lot of us need to think about, as well as development standards specifically for data integration. And don't forget, if you want long-term success, you need the business people involved. For one thing, the hub will give them friendly views of source data, give them publish and subscribe for self-service, but also through their involvement through this collaboration, it also just helps data integration work be more tightly aligned with what the business needs. So a few recommendations at the end. I think more people need to admit it. Architecture is a requirement of data integration. I mentioned earlier, I still find people who think data integration is just some dark corner in data warehousing, and therefore data integration doesn't need its own architecture. The warehouse has an architecture or something like that. I don't agree. I think the warehouse definitely has its own architecture. I think data integration has its own. There are obviously going to be overlaps, no doubt about it. But if you really want to control the growing complexity, the growing number of solutions that many of you are supporting through one data integration platform, a hub-based approach is really going to help you with that. You need architecture. So establish an architecture, stick with it, figure out what are the standards. A lot of the standards are preferences. What's our preferred interface for certain situations? What's our preferred development method in others, etc. And go with a hub, not a hairball. I think that's pretty obvious in the way I'm talking. And seriously, adopt a hub and spoke architecture for most data integration implementations. It's easily understood, simplifies things. It's easy for people to pick up your work, to debug it, add value to it, that kind of thing. It enables reuse and a lot of collaboration. So when you're looking for a next-generation data integration hub, I personally feel this is something you should buy. You should not try to build it. That way you'll get the greatest feature set, and a lot of the advanced stuff I've talked about today, like publish and subscribe, and some of the newer data integration function around event processing, you just can't really build that yourself. I mean, let's just be honest about it. So I think this is a buy, not a build proposition, and because of those differentiating features. All right, well, that brings me to the end of my part of today's webinar. Di, if you don't mind, come in and segue us to the next speaker.
Will do. Thanks, Philip. Okay, let me jump in with a quick reminder to our audience here. If you have a question for either speaker, go ahead and type that into the question area on your console and send it over. Again, we'll be answering audience questions in the final portion of today's event right after our next speaker. Joining us today from Informatica is Ronan Schwartz. Ronan is Vice President and General Manager for Emerging Technologies at Informatica. He's spent over 12 years in the middleware market, developing a deep knowledge and understanding of various industry B2B initiatives, standards, and formats. His experience includes large-scale integration projects, such as ERP, ETL, BI, and B2B implementations, both here in the States and in the United Kingdom. In his current role, Ronan is responsible for product management and marketing for a number of Informatica product lines. Those include B2B, Data Integration Hub, Ultra Messaging, Complex Event Processing, Data Replication, and Data Services Technologies. Ronan, welcome to TDWI.
Hi, thank you, Philip, and thank you, Diane, for the introduction. And I'm also very excited about the Data Integration Hub emerging pattern. I think it is very timely for the level of complexity that the market is seeing out there. In the next 10 minutes, my goal is to share my experience with Data Integration Hub, try to explain a new Informatica offering that helps customer put architecture into the data integration, leveraging a hub approach, and also a bit about how to start building a business case to implement the data integration hub. The first place that I want to start with is a very common first meeting that I have with customers. In this meeting, customers are usually sharing their current architecture. I think if I follow Philip, it's usually the current lack of architecture, and they're putting on the board or on the computer screen a very full screen that shows a lot of lines going between many applications. What you're seeing on the screen right now is a very downsized example of that. This was not the goal that they started with. Many of them started with a very clean picture where applications are directly connected to a single ODS, a single data warehouse with a single BI layer. Unfortunately, over time, there've become more need for application-to-application directly talking to each other. Additional departmental BI implementation requested more specific information only from the department application. Mergers and acquisition put more and more requirements and more application, and really created this hairball. If we're looking further into this hairball, then this is really affecting our daily life, especially the people in the data integration business, and every consumer of the data inside the organization is affected by this hairball. There is a lot of yellow sticky notes here on the screen that are kind of coming to show these specific pain points as the customers are seeing them. But if we're looking into the business side, then there are questions like, how can I comply to regulation while I don't know where the data is coming from? How can I really trust it? Data is heavily redundant. How can I reduce the number of copies that I keep creating in order to be able to analyze the data? And if we're looking into the integration side of the house, then there is a need to get data faster to different systems. And how can I get the data in real time while I can check quality and consistently in a dynamic way? There is a lot of pain around the business asking for more information, but it just takes too long, and the backlog is just too big to support real critical initiatives that are running right now. There are too many new BI systems that are scattered across different source systems. Which is the correct report when two people are coming to the same meeting with different data sets. And I think above all, there are just too many point-to-point interfaces that make the overall system fragile. Too many things can break, too many dependencies that really prevent innovation from coming out. This doesn't have to be the reality, and I think Philip have shared that greatly. We in Informatica believe that the concept of a data integration hub with the right software support can enable a much cleaner and faster implementation, where basically the hub is the single target of all of the publishers of data, and actually is the single source for all the subscribers. And by that, creating a single point where you can actually ensure quality, ensure delivery on time, and ensure simplicity of publishing and subscribing to data. Let me just let the slide switch. And my next goal is actually to show you Informatica Data Integration Hub principles and really share with you how can that work. How can the new data integration offering really change the way people are doing integration inside the enterprise. And if we're looking into the next slide, and hopefully the animation will be able to demonstrate it, when an application owner wants to publish data from a new application or a new system, he basically needs to simply define what data is needed to be delivered from his application. And Informatica Data Integration Hub really allows application owners to publish the relevant data into the Data Integration Hub. The data is then persisted by the hub and distributed to all the subscribers for the specific data topic. So subscribers can subscribe to subset of the data and the specific data topics, and that's what they are receiving from the hub. As part of the interaction management, the subscriber can specify for each topic the timing that he wants the data to be delivered in, the filters on the data, and the projection, what fields of the data he really wants to receive. This is enabling a full decoupling of the publisher and the subscriber, and the persistent is fully automated, which actually simplify the whole process. The fact that this is all done through business configuration is enabling self-service when every application owner or data owner can both publish and subscribe, and reduce the application onboarding time and the interface development time by more than 80%. The hub can also be leveraged as a central data management layer to enforce consistent data, to ensure data quality, to run transformation and validation rules on the different publication, and last but not least important, it gives you a single point to monitor and control who is sending and who is receiving the data. The data integration time gives real-time visibility to the data itself, to the integration SLAs, and to see that everybody is receiving the information they need in a timely manner. If I'm going into the next slide, I want to talk about a few of the key components that are part of the data integration hub. The first one, and I'm here connecting into what Philip already mentioned, is to enable publish and subscribe to the data itself. Let me just let the screen update. And by enabling publish and subscribe integration for both batch and real-time, application integration is becoming significantly simpler. It is reducing the dependency between one application and the other, because each one of them is communicating with the hub only. It does enable also self-managed persistency, meaning that the data that is published from one application is waiting for all the consumer of the data to receive it, and then keep it for a short predefined time and remove it. So there is a self-managed persistency here as well. That also includes the ability to define new topics and new persistency requirements, and all of that is kind of self-managed. Data can be certified in the hub, ensuring the trust of the data, the quality of the data, and the timeliness of the data. And last, the end-to-end visibility to the data integration. So you can see that your data is actually being consumed, who consume it, and there is better accountability and compliance to the data delivery. I want to finish with two last slides. One is defining a few common use cases, and the next one is discussing where can you see some of the value coming from a data integration hub. So the first example that I want to share is of a large bank in Europe. Their challenge is actually hundreds of batch processes used to integrate large application, including mainframe application, with external sources as well as internal sources. The problem is basically that hundreds of these integration processes are demanding consistent maintenance and consistent changes. Even if every application is changing only once in every 5 years, it means that there is more than a single interface is changing on a daily basis. So this is kind of a very, very big problem for the organization, and this is a classical place that they can achieve a significant ROI from a data integration hub. The second example is of a large insurance company. PubSub's solution is enabling them to manage the data sharing, especially data sharing coming on new products, new pricing proposals, and they're able to share that information very effectively in a PubSub manner with agents inside the organization as well as independent agents. This is especially enabling them to allow the agent to self-service themselves, to filter the relevant data by region and by product line. The next example is of a global manufacturing company where they need to manage hundreds of interfaces between multiple SAP systems and other operational systems. The focus on application integration and management monitoring is requiring them to get better visibility to who is publishing what information and who is consuming that information, and manage that problem. The last example here is of a global retailer, and this global retailer is standardizing on pub-sub integration pattern for purchase orders and shipping notices with backend applications like ERP and CRMs, as well as cloud application. This is especially important to this global retailer, as this global retailer is going through a lot of changes right now, moving from on-premise system to cloud system that are requiring a lot of updates to the interfaces. PubSub is actually making that significantly simplifying that process. My last slide here is going to focus on the benefits of the Data Integration Hub, and this is something that you can take into building your business case to why you should try and look into Data Integration Hub as the next data integration initiative. The first benefit is reducing the cost of data integration and achieving operational efficiency, where we are seeing about 50% reduction in the amount of efforts in maintenance of existing interfaces. The next part is better business agility and faster information delivery. And this is something that is especially affecting large application implementation initiatives. Data Integration Hub can get this application live much faster. In continuation of that, getting a new application is requiring now less of the central IT effort and more of the specific application or business efforts, because self-service is allowing the new application to subscribe to the data that it needs and allow it to publish relevant data for other applications without the need for a person to actually understand both sides very well. It does enable better business operations because the hub does ensure the data quality and data timeliness and allow you to validate that the data is trusted. At the end, there are some new regulations in certain industries that are defining a harder compliance requirement. With centralized data governance inside the hub that ensures audit trails and tracking of the data, it's much easier to answer to these new regulations. And then this kind of concludes the slides that I wanted to share with the audience, and thank you everybody for giving me the time to share this exciting topic with you.
Thanks, Ronen. Okay, we're now going to move into our question and answer period. Looks like we've got some great questions from the audience waiting in the queue, so let's see how many of these we can get to. I'm going to start with a question for you, Philip. Somebody was rather captivated by that Roach Motel analogy of yours. She's wondering, what are the modeling techniques to avoid the Roach Motel? Can you suggest anything?
Yeah, the Roach Motel is not so much about data modeling, if that's the kind of model she means. It's really about the direction of your data flow. With the Roach Motel, it's just one way into the motel, and quite often doesn't come back out. Also, it's just too simple a flow. It's from point A to point B. So most of the work, if you really want to get value from data, you have to be able to get the data back out. Like I mentioned, one of the attributes of a true hub is that you want to improve the data on the hub before it comes back out, and that's something I don't see enough of in sort of homegrown hubs as well. And then kind of a general, I can sort of segue into general issues around data modeling. You know, what we're talking about today with hub and spoke is really a computing architecture. It's not a data model, but there are certainly roles for data models within the architecture. For example, quite often it's at the hub where data in a particular schema coming from certain sources is transformed at the hub and transformed into a different data model. And then also there's another question here. Somebody asks, well, can the data warehouse be a consumer of the hub? Oh, yeah, absolutely. Data warehouses are typically consumers. So sometimes if you're loading a data warehouse from the hub, you will actually remodel the same data on the data integration hub a few times because that same data gets used in different places in the warehouse. For example, one of the simplest things would be to sort data. So if you have data that you want to load into a geography dimension, you might sort data by a zip code. If you want to load data into some other dimension like a customer demographic, you might sort the data according to that to begin, or you might completely redefine it. Quite often we have to have calculated values that go into things like time series in the warehouse. So a lot of the calculations happen on the data integration hub in the warehouse. So there's a lot of possibilities there, I mentioned the data hub could tie into a data warehouse. You know, the larger hubs that I see users using are actually truly enterprise data integration. So it's not just, we're not just talking about data warehousing. We're talking about most of the data replication and synchronization operations through the enterprise, as well as those that demand ETL, federation, and so forth, and even data quality can go through a single hub.
Great, thanks. Okay, Ronan, I've got a question here for you. Where are customers seeing return on investment from their data integration hub implementations?
I think this is a great question, and I think different implementations see it in different places, but the most common place is actually with faster respond of IT to new immediate projects. So from the first project that is running right now, a new application coming on board, a new strategic initiative, with a data integration hub implemented, you can actually reduce the time to delivery of that project. I think the second most commonplace is with overhead cost of just regular maintenance and regular changes, including in that things like upgrade of a major ERP system, moving of a CRM system to the cloud, and so on. I think the last one that I want to mention here is a large merger or an acquisition. A large merger or acquisition usually requires creating a lot of interfaces. Putting these interfaces through the hub can give a very fast ROI.
Very good. Philip, I've got a question here for you. With the explosion of big data, is it imperative that data integrations scale and get parallelized? Somebody's wondering, how do we adapt data integration architecture with the Hadoop ecosystem?
Oh, yeah, this is one of the coolest questions I've had in a while. Yeah, it's true, isn't it? We need to look into the future. I know many organizations are looking at finding a permanent place for various Hadoop technologies in their world. And so Hadoop needs to integrate with the other enterprise systems, right? It should not be a silo, and of course it can be integrated. So as kind of a first phase deliverable for finding a way to connect Hadoop through a data integration hub and other integration infrastructures, you simply need the interfaces, right? And I think the data integration vendors pretty much across the board are doing a really fine job working out new interfaces, APIs, call interfaces, etc., to the Hadoop environment. Now, the catch is we say Hadoop as if it's one thing, but it's not, is it? It's actually a whole family, a growing family of products. Now, there's always the Hadoop Distributed File System, or HDFS, at the foundation of it all, but almost all users will layer MapReduce above that, and sometimes, and MapReduce some people say MapReduce provides analytics. No, MapReduce provides a general purpose way to take just practically any kind of logic or data access and make it fully parallelized, right? And that can be analytics, but could be anything else, including data integration. So we're seeing the vendors actually leveraging the power and parallel processing for scalability and speed of MapReduce. And so the interface is not actually to HDFS, it's through MapReduce. Likewise, some users will layer Hive over MapReduce, and Hive has its own query language and kind of looks like SQL. You can learn SQL. You can learn HiveQL quickly, but doesn't solve your compatibility problems with tools and including data integration hubs that quite often assume standard SQL. But the vendors are doing a really good job of doing things like, go ahead and generate SQL in their environment, but translate it to HiveQL and pass it there, and then the HiveQL is processed by MapReduce for the greatest speed and scalability. As we move forward, other bits there the data integration is tapping into, so interfaces to HBase, which is a record store that brings some database functionality to the non-database called Hadoop. And then finally, if you're doing interfaces and through Hive and MapReduce, those assume a fair amount of data latency. They're really designed to be long-running, batch-oriented type queries and data processing. So we do have new, exciting functionality coming with Hadoop in the form of Impala, Stinger, Shark, which are going to give much faster, even interactive query access to Hadoop. So I see data integration vendors starting to provide interfaces there. So sorry for the long answer, but it's Hadoop's fault. It's because there's so many pieces of Hadoop that you could interface to.
And Philip, if I may add one more thing that I'm seeing in the market, I've seen one of the earliest pattern in the data integration hub is making a Hadoop or a specific Hadoop application a subscriber of the data, and by that actually enabling to move a lot of the data into Hadoop in a very efficient way. Another data integration hub implementation, or actually looking into Hadoop, is the longer-term persistency layer. So there is a short-term persistency layer that is kind of moving the data in real time into different application, but then you can keep the data for the longest time, for the longer time inside Hadoop as a larger persistency layer that is available for different applications to subscribe to the data or to kind of synchronize with a larger set of data in the longer term.
That's a really good point, and data integration tools and now hubs have a long history of having various data staging areas associated with them. I bring it up because I see a couple of questions about persisting data in or near the data integration hub, and so nowadays we're seeing a lot of folks experimenting with Hadoop as a new, bigger, and capable of handling a more diverse range of data than systems they've used for data staging in the past. So yeah, some of what you said there makes me think of using data integration with Hadoop as a staging area. And that's where a lot of ETL processing in particular, but other forms of data integration and quality functioning, that actually happens with multiple passes over data that's in the staging area. And so that makes Hadoop an even more important part of the architecture for data integration.
Good. Okay. Ronan, here's a question for you. Could you describe or give a rule of thumb for what kinds and how much business logic should or could be in the data integration hub?
Yeah, I think it's an excellent question, and I would recommend by default to have inside the data integration hub more of the rules that are validating the data itself. So I think the question about what logic should be, it's more the logic that is required to validate that the data is actually trusted, that the data is in the format and with the values that everybody can consume it. I will actually do the rest of the transformation that are needed per application more on the receiving application side. And I think I do want to kind of connect it also to another question that is kind of asking how do you do these things and how do you measure the performance of these transformation or these rules. Basically, the data integration hub is based on Power Center. On Informatica data integration hub is based on Power Center, meaning that you do have the full capabilities to run these complex transformation, complex validation rules, and so on. And from a performance perspective, it is extremely scalable, so it doesn't actually have a hard limitation on the amount of data that is moving.
Okay. Unfortunately, we're just about out of time here. I'd like to thank our speakers for their presentations today. So thanks to Phil Russum with TDWI and Ronan Schwartz with Informatica. Of course, we also want to extend our thanks again to today's sponsor, Informatica. I'd also like to remind you that you can obtain a copy of today's presentation by clicking on the click here to download a PDF line there on your console. In addition, we'll be emailing you a link to an archived version of the presentation. And if you've asked a question that we haven't had time to answer, and there are quite a few questions we haven't had a chance to get to, please note that we'll answer remaining questions individually via email. Finally, I'd like to remind you that TDWI offers a wealth of information, including the latest research, reports, webinars, and information on business intelligence, data warehousing, and a host of related hub-related topics. So I encourage you to tap into that expertise at tdwi.org. And with that, from all of us here today, thank you very much for attending. This concludes today's event.